Dear mentors, in this video we'll briefly talk about fraction addition, especially how to explain it conceptually rather than procedurally. So I'm sure in other videos you saw how we talk about procedural knowledge versus conceptual knowledge, how both are important and how one helps actually the other one. So in this video I want to explain a fraction problem, just a fraction addition, that I can do rather than using procedures, using conceptual understanding. So let's go ahead and consider the following example. So let's add 1/2 and 3/4. And so there's several ways you can do that. So let's do first something that we could call line method. And of course you could call it in many different forms. And it goes like this. So what you want to do always is relate fractions to the unit, because a fraction is built in the sense that you start with a unit and then you consider some part of that unit. So what we could do is the following. We start with this and we say that this is 1. And this is especially important for students that are struggling with fractions conceptually. So you want to go back and relate to integers, because they might be more familiar with integers, and then go from there. And so then you could ask, how can you represent 1/2? What is the meaning of 1/2? And have him explain that in terms of pieces, in terms of parts, equal parts, using this language that relates more to actions rather than just to formulas or to just expressions. So 1/2, you could have this 1 broken into 2 equal pieces and take one of them. And notice how I want to do these bars or these lines in such a way that they actually align each other so that I can compare. And so that's a good habit. And you could do it first just yourself and then ask the student to replicate and to help you do it. And so then you could ask, what is 3/4? So how can we represent 3/4? So that's a little more involved, because it's going to be now 3 parts of the unit that was now divided not in 2, but in 4 parts. And so here in this conceptual trip, in this conceptual explanation, you could also relate how dividing by 4 is the same as first dividing by 2, and then dividing by 2 again, which is not just useful for these pictures that we're drawing, but it actually helps build understanding of the relation between halves and fourths. So this is the picture, and now we would select 3 parts. And so here it's more natural, the concept of a common denominator of a fraction. So you could ask the kid now, in my first model, so my original model, which you may always start with a 1, how can we see these other 2 models? How can we see them both in the same place? And really that's the key to common denominator, right? We want a common language because we got 2 fractions that were phrased in different languages. And when I say language, it's just the denominator. And we want to make sense of that. So here's what happens. Well, this green line, we can put it here. And these lines, we can put them also here. And so then you could ask the student to go back to the models. And so that now the original model, makes these other 2 models inherit these divisions. And so what we're going to do is this. And then we're going to do this, which we really don't need, but it's important conceptually to understand. And then the kid right away see, oh, I'm adding, so I'm just collecting these parts, and I have 1, 2, 3, 4, 5. So let's say 5 parts, or 5 pieces of equal size. And then you could ask, what's the size of each piece? And it'll be clear that it's 1/4. Why? Well, because if you look at the original, it's now divided into 1 piece. So each of size, and now again, you could use size, length, 1/4. So the answer to the problem should be then 5 times the quantity 1/4, which now we put into formal language, so that's 5/4. And so that's how we would do it. Let's check with procedures. It's also a good idea, because then you can see the connection between this conceptual explanation and the procedures. So you could do something, we could call it a check for our students, and then we would add 1/2 plus 3/4 by looking at a common denominator. So that's going to be 2/4 plus 3/4. And notice how I picked an example in such a way that one of the denominators is a divisor of the other one. So I don't want to start with a complicated example. I'd rather start with just some little tiny complexity and then, bring it up. And so this is 5/4. Let's illustrate a second method that we would call the area method. So in a sense, it's just a two-dimensional application now, or a two-dimensional consideration. And so the area method would be like this. You would start with a unit, and you would say this is a unit. And you could take a square, or you could take a rectangle. And then you want to say, how do we represent 1/2? So it's going to be the same. That's the full unit. And so 1/2 would be, break this into 2 equal parts. And that's 1/2. Now, how do we represent 3/4? Well, we'll break it into 4 parts. And so here comes the important step. We could break it in many, many ways. But you could also tell the kid that since you're adding fractions, you would like to break the second square in such a way that it's compatible, or that it's, it's not too far away from the first way you broke it up. So you would just draw this line again. And then you could draw another line. This is 4 parts. And you're talking about 3/4. So I'm going a little faster now. But it's the same concept as before. And then again, you would ask your student, how can we make these two diagrams compatible, in the sense that all the divisions are in both of the models? So it's a matter of this line putting it here, and this line here also replicating it here. And we're making visible the concept of a common denominator. So now it's the same. You'll see 5 pieces, each of size 1/4. So 5 times 1/4. And that's 5/4. So I hope in this video you've learned how you can use pictures, whether it's in 1 dimension or 2 dimensions, to convince your students how to add fractions. And along the way, they're just practicing many different things like spatial reasoning, number sense, etc. Thank you.